Planet Earth was formed some 4,500 million years ago. During that time, all the water on our planet has been circulating in a continuous natural cycle in which different forms of life that exist or have existed are also included. Water in its different forms can be found in rivers, seas, lakes, the atmosphere, in deep and superficial layers of the Earth, and also in the distinct forms of life that we know. For example, a jellyfish is 90% water, and we humans are approximately 65% water. We are part of the water cycle. This bottle represents all the water on planet Earth. Approximately 95.6% is found in oceans. Only 2.5% of the total is freshwater. However, all the freshwater of the planet is not available for human consumption. Just over half is found in ice caps, and a third is groundwater. In fact, only 1.2% is found in freshwater rivers and lakes. Approximately 70% is used in agriculture, 22% in industry, and the rest, 8%, is the amount of water we use in our everyday life. We depend on this small portion of water to live. It is vital to preserve it. The use of fresh water in agricultural and industrial works and part for human consumption involves water pollution. As a consequence, pollutants such as heavy metals, pesticides, fertilizers, etc. appear in wastewater. These types of conventional pollutants are regulated by public institutions. However, alongside the conventional ones, we must include what are known as emerging pollutants, such as personal care and hygiene products or the remains of medicines, or even drugs that are not metabolized by our body. There's no doubt that life expectancy in the developed world has increased, thanks, among other things, to the common use of hygiene products and medicines. However, a large part of these emerging pollutants end up in the water cycle. Are we aware that we are overexposed to these pollutants? In other words, are we aware that these kinds of pollutants can reach the water distribution cycle and that we even be drinking the remains of these products? Dr. Veronica Pino is a researcher in analytical chemistry at the University of La Laguna.
The truth of the matter is that these compounds are found at very low concentration levels in water, in the range of parts per billion or trillion, depending on the pollutant. To give a rough idea, it would be like finding a grain of salt in an Olympic swimming pool. For that reason, very sophisticated analytical techniques are required. While it may appear that this amount is insignificant, in fact, these pollutants are harmful to health, even at low levels. To start finding a solution to this problem, it's necessary to carry out an exhaustive water analysis to determine the exact presence of these pollutants.
For example, ibuprofen is a commonly used anti-inflammatory. Approximately 10% of the ibuprofen we consume is removed unaltered in urine, and this is a problem urgently in need of resolution, as difficulties related to drinking water are already common in our region. Researchers around the world work to develop detection systems, monitoring and cleanup for emerging pollutants in water. Also, at the University of La Laguna, we research new materials and analytic methodologies in a sustainable and environmentally friendly way. Dr. Catalina Ruiz-Perez leads the GAROÉ project.
The main objective of the Sustainable Materials for Selective Environmental Monitoring of Water Pollutants project, which the research team has called GAROÉ, is the synthesis and characterization of materials with specific functionality, primarily metal organic frameworks, the so-called MOFs, and ionic liquids, or ILLs. The ultimate purpose of this project is to monitor water quality through use of new sustainable materials, as well as environment-friendly analytical monitoring techniques. This is a challenge that has been taken on board in the European strategy known as Horizon 2020, as well as in the Spanish strategy for science and technology, which it is hoped will have an impact on those involved at the social and economic level. This integrated research approach is achieved through an interdisciplinary team, the members of which bring together different areas of expertise while sharing a common goal: the development of better procedures for monitoring water quality. The benefits of this project also include improvements in the local economy, an increase in public-private commitment, and the strengthening of the potential research carried out by the University of La Laguna.
Monitoring pollutants, both conventional and emerging, requires advanced materials capable of detecting them at very low concentration levels. Among others, we use MOFs, metal organic frameworks. A MOF is a crystalline material with homogeneous cavities capable of absorbing gases, liquids, and other substances. The distinctive feature of this material is that it can be designed to trap a specific pollutant. One of the methodologies we are using in the project entails adding these MOFs together with magnetic nanoparticles to the sample of water contaminated with ibuprofen. Once the MOF traps the ibuprofen molecules, a magnet allows us to separate both materials and pollutants from the water. Later, an analysis with instrumental techniques such as chromatography is carried out.
These techniques can provide the answer to pollution problems, as we intend to develop sustainable methods that respect the natural cycles of water and at the same time are affordable enough so that they are available in any laboratory without losing high selectivity or efficiency advantages.
Fresh water is a precious commodity. However, the easy accessibility to this resource in developed societies has trivialized its importance and the need to protect it. This is especially important in places like the Canary Islands. In our islands, the demographic pressure arising from the tourist industry and limited freshwater availability make maintaining the sustainability of the water cycle a crucial factor for the development of the region.